Hello everyone. Welcome back to the lecture series of ICSE 10th Maths chapter Mensuration. In previous video we started the sums from Selena publication. We did question number 5. In today's video we are going to start from question number 6. My name is Arpita Banerjee and you are watching Arpita classes. Let's get started. The first question is, a cylinder has a diameter of 20 cm. The area of the curved surface is 100 cm square. Find the height of the cylinder correct to 1 decimal place and the volume of the cylinder correct to 1 decimal place. So what all things are given? First of all, we are going to write the information, that is the cylinder has a diameter 20 cm. So diameter is denoted by D is equal to 20 cm. Immediately we are going to write R is equal to 10 cm. Radius is half of the diameter. The area of the curved surface is given. So the curved surface area is equal to 100 cm square. We need to find out the height, so we need to find out h is equal to what and volume is equal to what. So first of all, we are going to take the formula for the curved surface area of a cylinder, which is 2 pi r h, and that is equal to 100. We are going to put the values 2 into 22 by 7 into r we do not, r we know, r is 10, and h we do not know, that is equal to 100. We'll take all the values over there. So h is equal to 100, 7 will go up, 2, 22 and 10 will come down. So here 0 and 0 gets cancelled, 2 and this will be 5. So we are getting 35 upon 22 centimeter as the height. They told that we have to find out the height correct to 1 decimal place. So we just have to divide 35 by 22. So dividing 22, 1, 22, 3, 1.0. 6 is more, so we'll take 5, 2, 0. So it's coming 1.59. Since they told to correct till 1 decimal place, since this is 9, so this will be 6. So it will be approximately 1.6 centimeter. So this is the height of the cylinder. Second thing they are asking, find the volume correct to 1 decimal place. So let us find out the volume. I'll do it here. Second part is the volume. We'll put the formula for the volume, pi r square h. We'll put the values. Pi is 22 by 7. R is 10 into 10. And h, the value of h I'll put 35 by 22. So that whatever gets cancelled, it will get cancelled. We can cancel 22 and 22 from here, 7 and 5 from here. So we are getting 500 centimeter cube. So this is the volume. Let us start with the question number 7. It says a metal has an inner diameter of 5 centimeter. The pipe is 5 millimeter thick all round. Find the weight in kilogram of 2 meters of the pipe if 1 centimeter cube of the metal weighs 7.7 gram. So it has inner diameter 5 centimeter. So we'll denote the inner diameter by r, small r, 5 centimeter. And the thickness of the pipe is 5 millimeter. Let us convert millimeter into centimeter. So we'll have to divide by 10. So that is 0.5 centimeter. Find the weight in kilogram of 2 meters of the pipe. 2 meters of the pipe is the height of the pipe given. So h is equal to 2 meter. We'll convert into centimeter, that is 200 centimeter. Now the 1 centimeter cube of the pipe weighs, metal weighs 7.7 gram, that's given. So that means here we need to find out the volume of the pipe. And since 1 centimeter cube weighs 7.7 gram, therefore the total volume of the pipe weighs how much? That is the answer. Okay, so let us find out the volume of the pipe. Volume is equal to pi. Now this seems to be a hollow pipe because it is the inner diameter is given and the thickness is given. So the volume will be pi capital R square h minus pi small r square h, where capital R is the outer diameter and small r is the inner diameter. So we'll take pi h common from here. Inside the bracket it's r square minus small r square. Let us put the value. Pi is 22 by 7, h is 200. Now capital R will be, we'll find out here, capital R will be inner r plus the thickness. So that means inner r is 5 plus the thickness is 0.5, so that will be 5.5 centimeter. So it will be 5.5 centimeter square minus inner diameter is 5 square. Now, so since it is coming a square minus b square, we can write a plus b into a minus b for this. So 22/7 into 200 into 5.5 plus 5 whole into 5.5 minus 5. So I wrote a plus b into a minus b. So that gives me 22/7 into 200. 5.5 plus 5 will give you 10.5 and 5.5 minus 5 will give you 0.5. This will get cancelled. 7 ones is 7. 1.5 this is. So this is coming 22 into 200 into 1.5 into 0.5 centimeter cube. So this is the volume of the metal. Now here they are saying 1 centimeter cube of the metal weighs 7.7 gram. Therefore this volume weighs how much? Therefore total weight of the metal, is equal to the volume into 7.7. So the volume is 22 into 200 into 1.5 into 0.5 into 7.7 gram. So when you do this calculation, you get the answer. Here I have already done the calculation. It's coming 13.31 kg. 1728 versus 13.31 kg. That means you divide the whole thing by 1000 to convert it into kg, and finally the answer comes 13.31 kg. So in the next question, a cylinder container with diameter of base 42 centimeter and contains sufficient water to submerge a rectangular solid of iron with dimensions 22 by 14 by 10.5 centimeter. Find the rise in the water level when the solid is submerged. That means there is a cylinder like this. Which is having some dimensions, and there is a solid which is having some dimension, and that is submerged. This is full of water. This contains sufficient water, they are saying. So that is, suppose this much is water here, and now this is submerged in this. This iron block is submerged in this. So how much the level of water after submerging? Maybe the level of water rises this much. So you need to find out the level of water. This is a question. So whenever this type of question is asked, always remember the volume of the solid will be equal to the volume of the water level, which is risen up. Because it is Archimedes principle. When you submerge something or immerse something in a liquid partially or completely, then some volume of liquid is displaced, and that volume is equal to the volume of the solid which is immersed. This is Archimedes principle. So we have to use this concept out here. Cylinder container with diameter. So now the diameter of the cylinder is 42 centimeter. So the radius of the cylinder will be 21 centimeter. It contains sufficient water. A rectangular solid of iron with dimensions 22. Now the solid is having dimension, that is length is equal to 22 centimeter, breadth is equal to 14 centimeter, and height is equal to 10.5 centimeter. This is given. So suppose when it is immersed in the water, let the rise in water level is h. Okay, so let the rise in water level is h. This is the cylinder. We are talking about the cylinder over here. Okay, so volume of water level increased in cylinder is equal to volume of solid. This is what is Archimedes principle. So here it will be pi r square h. Here it will be length into breadth into height, because it is a rectangular solid. So pi is 22/7, r is 21 into 21, h we do not know, l is 22, b is 14, height is 10.5. So from here 21 and 21 will get cancelled. Here it is getting cancelled. So this is coming 3 into 21 into h is 14 into 10.5. Therefore h is equal to 14 into 10.5 divided by 3 into 21. We'll cancel this with 7, 7, 3, 7, 1, 0.5, this will be 3, 0.5. So it is 14 into 0.5 upon 3. It's coming 14 into 0.5 upon 3. So that is 7 upon 3. 7 upon 3 is 3 to the 6, 1 upon 3. Yes, this much. And what will be the unit? Centimeter. So the water level rises till 2 whole 1 by 3 centimeter. Question number 9. A cylindrical container with internal radius of its base 10 centimeter contains water up to a height of 7 centimeter. Find the area of the wet surface of the cylinder. So how it is? Suppose there is a cylindrical container like this, okay, whose base radius is given, that is 10 centimeter. So this is the base radius, which is 10 centimeter, and it is carrying water, it contains water up to a certain level. That level is, suppose this is H is equal to 7 centimeter. It contains water till this level. They are asking find the area of the water surface, wet surface of the cylinder. So it's very clearly the wet surface will be the inner curved surface area of the cylinder and the base area. So inner curved surface area and the base area, this much area will be wet. So that is what we have to find out. So here R is equal to 10 centimeter and H is equal to 7 centimeter. So area of wet surface of the cylinder will be is equal to the inner surface area, that is 2 pi RH, plus the base area, that is pi r square. Let us take pi r common from here, so it is 2h plus r. Let us put the value 22 by 7, r is 10, 2 into h is 7 plus 10. So it's 22 by 7 into 10, 14 plus 10. 14 plus 10 is 24. So it's 22 by 7 into 10 into 24. So if we calculate this, we'll get the answer. I have already calculated and it is coming 754.29 centimeter square. 754.29 centimeter square. So this is the area of the wet surface of the cylinder. Question number 10. Find the total surface area of an open pipe of length 50 centimeter, external diameter 20 centimeter and internal diameter is 6 centimeter. So we have an open pipe, both sides open. It is a hollow pipe since the external and internal diameter is given. We have to find out the total surface area of the pipe. So definitely the total surface area is the outer curved surface area plus the inner curved surface area, because there are two pipes. Understand, there is a bigger pipe and there is a smaller pipe is inserted inside that. So the outer curved surface area, that is 2 pi capital RH, plus the inner curved surface area, that is 2 pi small rh. Also this ring will come, this ring, we have to find out the area of this ring, because even this is there. It's a hollow pipe, so inside it is hollow, but this ring is there. So this ring will be pi capital R square minus small r square. Pi capital R square minus small r square. But there are two rings like that, okay? So first we'll write down the length of the pipe is, that is h is equal to 50 centimeter. External diameter I am denoting by capital R, which is 20 centimeter. External diameter, sorry, so it will be denoted by capital D, which is 20 centimeter. So capital R will be 10 centimeter. Internal diameter, that is small d, 6 centimeter. So internal R will be 3 centimeter. So we need to find out the total surface area of this. So TSA is equal to 2 pi RH, 2 pi capital RH plus 2 pi small rh plus 2 pi capital R square minus small r square. Okay, we have to find out 2 pi capital R square minus small r square, because there are two rings like that. So it is the outer curved surface area plus the inner curved surface area plus two rings, the area of the two rings. Okay, so let us take from these two we can take, or from all the three terms we can take 2 pi common. So if I take 2 pi common, inside the bracket I get RH plus small rh plus r square minus small r square. So let us calculate this. 2 into pi, pi is 22 by 7. Capital R is 10 into h is 50 plus small r is 3 into h is 50 plus here we can write a square minus b square, it is so a plus b into a minus b. RH plus, plus a plus b into a minus b, so that is capital R plus small r into capital R minus small r. So it comes 2 into 22 by 7, 500 plus 150 plus 13 into 7. So 2 into 22 by 7, 500 plus 150 plus 91. So that is 2 into 22 by 7 into 500, 150, 650 plus 91. So 650 plus 91 gives 741. So when we calculate this, we get the answer. I have already done the calculation over here. So it is coming 4657.71 centimeter square. 4657.71 centimeter square. So this is the total surface area of this solid. In today's video, we have done another 5 questions. That is still question number 10. Next video, we will continue with the next sums from Selena publication. This is exercise 20A as per my book. So we will do the next questions from 11th onwards. Thank you so much. Stay tuned.